You are welcome to today's class. Today we want to discuss Radix point. The last class we discussed hexadecimal. So far we have done number systems, positional systems. So far we have done one number system. We've done positional system. We have also discussed uh, exponent zero, right? So today we want to discuss radix point. Now, what we have said so far is that number system defines symbols, right? Number system define symbols. And then the positional system gives meaning to this symbol. Now, when position enters into a system, mathematics becomes structural. That's what we have said. Then exponent zero anchors the system, right? Anchors system. Because base raised to power 0 equals to what? 1. Then every other digit that we are going to count or symbol we are going to use will be in reference what? To what? To this 1. So that is what we have discussed so far. So today we want to look at radix point. So what is a radix point? Radix point is a symbol that is used to separate the whole power from what? From the fractional power. So when we say in decimal, we call it decimal number, decimal point. Right? In binary, we call it binary point. In hexadecimal, we call it hexadecimal point. Now, the general name for this is what? Radix point. Because radix is for what? Base. So for each base, like we have decimal point. So for this decimal point, we have something like 5.625. So this is decimal point. In binary, we have 101.101. This is base 2. This is base 10. Right? In hexadecimal, we have something like AF, right, dot 2. This is base 16. So this point, and this point is what we are calling radix point. So what does it do? It separates the whole power from the fractional power. So I'm going to show you what I mean by that in this class. Okay. Now, if we have something like what I just did, 5.625, right? What does this simply mean? With this radix point, so we are going to say 5 times in decimal times 10 plus 6 times 10 plus 2 times 10 plus 5 times 10. Now, with this, because of this decimal point, this is 5, right? So this place will be what? Raised power 0. Now, this one will be what? Minus 1. This one will be what? Minus 2. And this one will be what? Minus 3. So if we have something like 625.625, that will be what? Plus 2 times 10 raised power, this is 0, this is 1. And then we have 6 times 10 plus raised power what? 2. Now, if you look at this, 625.625. Now, the radix point is helping us to determine the position of what? Of the exponent 0, which is what? exponent 0. So which is this one. So these radix points help us to determine that. Now to the left of the radix point, we are increasing. While to the right of the radix point, we are decreasing. So if you look at this is the same thing as saying 6 times 100 plus 2 times 10 plus 5 times anything raised power 0 is what? 1. Plus this is the same thing as 6 over what? 10, which will give us 0.6. Now, that is something I want you to observe. So this will give us 0.6 plus this will give us 2 over what? 100. That will give us 0.02, right? Plus this will be what? 5 over what? Over 1000. That will give us 0.05. 1, 2, 3. Right? So this will give us 0.005. Now, if you add all of them together, this will give us 600 plus 20 plus 5 plus 0.6 plus 0.02 plus 0.005. And this will give us 625, right? Plus, so this part will give us 0.6, 0.02, 0.005. This will give us 526.0. So this will be what? 0.625. And that will bring us back to 625.625, which is what we had before. Now, what I want you to observe in this is that this negative power does not mean negative number. So even though the power is negative, the number itself is still positive, but very, very small number. So when we are looking at the radix point, what the radix point actually helps us to achieve is what? Symmetry. It helps us to achieve symmetry, meaning higher number and lower number, higher positive number and lower positive number. So we are not dealing with negative number yet. So don't confuse this. Don't confuse this radix point with your number line. Let's say you have this. So your number line, you're having positive, 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 negative, 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 positive, 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 positive. Now, this is your number line. This is different from this power. So even though the power is negative, it's still giving you number line in positive. So what number system is actually showing you, based on what we have seen now, is that number system is showing you two things: magnitude, right, and direction. This is what we call vector in mathematics. We'll still get to that. So number system is actually showing you magnitude and direction. So the power is showing you magnitude, and then number system in itself, that is positive number and negative number, will show you what? Direction. So in this radix point, we are actually dealing with what? The magnitude. So the symmetry is that we can scale to a higher number, and we can also scale to a very small number. And this is what will help us to understand why our engineers or computers are able to deal with very, very small numbers. So that's what I want to show you. So this radix point now also gives birth to two systems, which is what? Fixed and floating point. This we'll still discuss in our other next classes. So this is what I want to show you. So the radix point helps you to see the position of the zero exponent. Now that is for decimal. We have the same thing for what? For binary. So we have the same thing for binary. So let's say we have 101.101. This is base 2. So how are you going to represent this? Same thing. 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. Now, 101, 101. So this one will be what? 0. This one will be what? 1. And this one will be 2. Then to the left of the radix point, right? This one will be what? Minus 1. This will be what? Minus 2. And this will be what? Minus 3. Now, if I am to convert this to decimal, this will simply give me 4 plus anything multiplied by 0 is 0. So 0 plus this is 1 plus 1 over 2. That will give me 0.5 plus 1 over 4. That is 2 raised to the power 2. This one will give me what? 0, 10, 2, 25. So this will give me 0.25 plus 0.3. That is 1, 2, and then 5. That is, this one is what? 1 over what? 2 raised to the power 3, that is 8. 1 over 8. So when you divide it, this is what you are going to get. Now when you add this will be plus this, that will give me 5.625. So this is what is going to give me in base 10. Right? So this is still what? Positive number. So what? Then I can convert this back. So the next class I'm going to teach you how to convert decimal back to binary, or how to convert the fractional part of any base to the fractional part of another base. That's what we'll do in the next class. So that is just what I want to show you in this class. What? The radix point. So the radix point helps to determine where the exponent 0 will sit in any number. But this is not negative. This is what? Still positive number. So we are now dealing with higher number and lower number. So this is what enables the computer to scale. So from the radix point, we enter symmetry. So that's what I want to show you in this class. So the next class, I will show you conversion of fractional powers from one base to another base. So don't forget to like, and if you have not subscribed, please do so. So we will see you in the next class. Bye-bye.